Hello, everyone. In this video, we'll explain how to connect a PostgreSQL database and send records to Salesforce using the SKYVVA agent. In this video, we'll show you how to connect a PostgreSQL database and send records to Salesforce using the SKYVVA agent. PostgreSQL and Salesforce are securely connected through the SKYVVA agent using a no-code, metadata-driven configuration designed for reliable, enterprise-grade integration. Query and retrieve. The SKYVVA agent executes SQL queries against PostgreSQL and retrieves only the records that match your configure criteria, such as records changed since the last synchronization. Transform and map. The mapping engine transforms PostgreSQL columns into Salesforce fields, applying mapping rules, data validation, and any required transformations before the data is sent. Synchronize with Salesforce. The transformed records are delivered to Salesforce using standard API operations, including insert, update, delete, or upsert, depending on your integration requirements. The result is a secure, automated, and scalable integration that supports reliable data migration, scheduled synchronization, and continuous data exchange without writing code. The SKYVVA agent makes PostgreSQL-to-Salesforce integration simple, reliable, and fully automated. Before learning how to configure the PostgreSQL database and send records to Salesforce using the SKYVVA agent, you should understand how to create the following SKYVVA components: integration, connection destination, database adapter, metadata provider, repository, message type, and interface. These components were explained in the previous videos, and they're required before you can configure insert, update, upsert, or delete operations. Once your prerequisites are complete, you're ready to configure your database operations: insert, update, upsert, and delete. Now let's get started. Navigate to the agent control board, then select the existing connection destination to make it online. Now click on the Adapter tab. Inside the adapter configuration, click Edit the PostgreSQL adapter. Although the configuration screen looks identical to other database adapters, we select the inbound direction and provide PostgreSQL-specific connection information, such as the JDBC driver class, username, password, hostname, port, database name, schema name, database URL, and link to the connection destination. Once configured, selecting Ping Connection verifies that the SKYVVA agent can successfully communicate with a PostgreSQL database. A successful connection confirms the adapter is ready for inbound configuration. Click Save the adapter. Once saved, we now have our inbound Postgres database adapter right here. In this scenario, we'll demonstrate 4 operation types used in Salesforce: insert, update, upsert, and delete. The interface configuration remains the same for each of these. The only difference is the operation being used. So now, let's navigate to the interface configured for the insert operation. This interface is linked to the message type generated from our Postgres database. Make sure to set the direction to inbound and select the insert operation. Then, click the Open Mapping button. Here, we'll map the PostgreSQL tables to Salesforce objects like account and contact, along with their required fields. As you know, with the insert operation in Salesforce, there's no need to set an external ID. However, for the database hierarchy level, we do need to define the foreign key for any table field that has a relationship with a parent table. We use the F-key checkbox to mark that foreign key. Once you've completed the mapping, click Save to finish. Once you've completed the mapping, the system will automatically generate the select query for the table and populate it in the database query field on the interface. Then, simply link the interface with the Postgres adapter. Before processing the interface, let's navigate to pgadmin first to verify that the records exist in the Postgres tables. Here are the records in the account_db table. And here are the records in the contact_DB table. Next, navigate to the Agent Control Board to process the interface. This will fetch the records from the Postgres database and insert them into Salesforce. In the Interface tab, we have 4 interfaces set up to demonstrate the different operation types. Select the interface. Click the Interface Processing button to process the interface. A pop-up screen will appear showing the manual execute options, giving you 2 choices. Option 1. Manually write or select a query to pull records from the database and send them to Salesforce using the query editor. Option 2. Use the database query field directly on the interface to execute and send the data to Salesforce. Select Option 2, then click Push. For inbound processing with the Postgres database adapter, you can process manually, start the scheduler, or use streaming. Once the processing is complete, head over to Message Monitoring to verify the results. You'll see the agent message displayed with green status indicators, along with the corresponding business messages for insertion of account and insertion of contact. Click on the message to open the message detail page. The message detail page shows the green status for the agent messages and displays comments for successful business messages, like insertion of account or insertion of contact, along with the actual data values here. Navigating over to Account in Salesforce. We can see that the new account and contact records have been created with all the map data from our Postgres database. As a result of Case 1, the data from Postgres was successfully imported into Salesforce, creating new account and contact records with all mapped fields intact. Because this was an insert operation, Salesforce generated new IDs automatically, without requiring an external ID. Currently, we'll look at the update operation. The interface configuration remains the same and stays linked to the same message type. We just need to edit the operation to update and then click Open Mapping. As you know, with the update operation in Salesforce, an external ID must be set so the system can query and locate the existing records to update. You also need to define the foreign key for any table fields that link to a parent table. Once you've completed the mapping, click Save to finish. We're using the same adapter, which is linked to this interface. Before running the process, let's head over to pgadmin to verify the records in our Postgres tables. Here are the records in the account_DB table, and here are the ones in contact_DB. We'll be updating the description field. Next, navigate to the Agent Control Board to process the interface. Select the interface, click the Interface Processing button, and then click Push. This will fetch the records from the Postgres database and update them into Salesforce. Once the processing is complete, head over to Message Monitoring to verify the results. You'll see the agent message displayed with green status indicators, along with the corresponding business messages for updation of account and updation of contact. Click on the message to open the message detail page. The message detail page shows the green status for the agent messages and displays comments for successful business messages, like updation of account or updation of contact, along with the actual data values here. Navigating to account record. We can see that the account and contact records have been updated with the map data example description from our Postgres database. As a result of Case 2, the data from Postgres was successfully updated in Salesforce, modifying the existing account and contact records, including updated fields like description, with all mapped data intact. Because this was an update operation, Salesforce matched the existing records using the external ID and updated them directly, without creating duplicate IDs. Currently, let's look at the Upsert operation. The interface configuration and message type link remain identical. Simply edit the operations setting to Upsert. Because Upsert handles both insert and update operations, click Open Mapping to configure the fields. The Upsert operation in Salesforce combines both insert and update functionality. Because of this, an external ID must be set so the system can locate existing records to update or insert new ones. You also need to define the foreign key for any linked tables. Once you've completed the mapping, click Save to finish. We're using the same adapter, which is linked to this interface. Before running the interface, let's head over to pgadmin to verify the records in our Postgres tables. Here are the records in the account_DB table, and here are the ones in contact_DB. As you can see, we've created one new record in these tables and updated some of the existing ones. Next, instead of running a manual execution, we can configure the scheduler to process the interface automatically at a set time. To set this up, configure the interface scheduler timing and execution interval and save the settings. Then start the scheduler time. Once the scheduler started, the screen displayed the submitted time, started time, and next scheduler run. When the scheduled time arrives, SKYVVA will fetch the records from the Postgres database and upsert them into Salesforce, meaning if an existing record is found, it updates it, and if not, it creates a new one. Head over to Message Monitoring to verify the results. You'll see the agent message displayed with green status indicators, along with the corresponding business messages for account and contact. Click on the message to open the message detail page. The message detail page shows green status indicators for the agent messages and displays comments based on the operation performed. It shows modification of account for updated records and creation of account for newly inserted ones, along with their actual data values. As a result of Case 3, the data from Postgres was successfully processed into Salesforce using the Upsert operation. Salesforce matched the updated records using the external ID and modified them in place, while automatically creating new IDs for any non-existing records. All mapped fields, including new entries and updated fields, were transferred intact without creating duplicate records. Currently, we'll look at the delete operation. The interface configuration remains the same and stays linked to the same message type. However, in this scenario, we map at the flat level. We just need to edit the operation to delete, and then click Open Mapping. With the delete operation in Salesforce, an external ID must be set so the system can query and locate the existing records to delete. Once you've completed the mapping, click Save to finish. We're using the same adapter, which is linked to this interface. Next, head over to the Agent Control Board to process the interface. Select your interface, click Interface Processing, and then click Push. This fetches the record IDs from the Postgres database and automatically deletes the matching records in Salesforce. Once the processing is complete, head over to Message Monitoring to verify the results. You'll see the agent message displayed with green status indicators, along with the corresponding business message for deletion of account. Click on the message to open the message detail page. The message detail page shows green status indicators for the agent message and displays the log comment deletion of account, confirming that the record was removed. Let's click on Accounts in Salesforce to confirm that the record was successfully deleted. For standard objects in Salesforce, like Account and Contact, if an account record is deleted, any contact records linked to that account are automatically deleted as well. As a result of Case 4, the target record was successfully deleted from Salesforce based on the data in Postgres. Because this was a delete operation using flat mapping, Salesforce used the external ID to query, locate, and remove the matching record directly from the org. To summarize, in this video we've demonstrated how SKYVVA seamlessly synchronizes data between PostgreSQL and Salesforce across the complete CRUD lifecycle. We created new records, updated existing records using external IDs, performed upserts by combining inserts and updates, and deleted records while leveraging Salesforce's standard cascade deletion. This completes our demonstration of PostgreSQL-to-Salesforce data synchronization with SKYVVA using manual processing via the interface and scheduled times. In a separate video, we'll explore streaming change data capture, also known as CDC, for continuous, real-time data integration. Thank you for watching. See you in the next video.